Hello, here is the question number 3 from JEE Advanced 2020, paper 1. It reads a small roller of diameter 20 centimeter has an axle of diameter 10 centimeter. It has been shown in this figure. It is on a horizontal floor and a meter scale is horizontally placed on its axle with one of its A's on the top of the axle. See the figure this. So this is the roller and this is the scale. Scale's one end has been placed over here, another end is here. Further it reads, the scale is now pushed slowly on the axle so that it moves without slipping on the axle. And the roller starts rolling without slipping. So it's a pure rolling condition at this contact as well as and this ground contact. After the roller has moved 50 centimeter, the position of the scale will look like what? There are 4 options and we need to mark the correct option that is going to be representing the final situation. So solution is here. Let me explain how to handle this. We can assume the center of this roller moves with VC velocity and the roller rotates with omega. It has to rotate. So if you push the scale like this center will be moving, this roller will be rotating. And we are assuming that the center moves with VC velocity and rotates with omega. Now, since on the ground it's having a pure rolling motion, so this B point should not have any relative velocity. B is one point is of the ground, another point is of the roller. So ground has a 0 velocity, hence this point should have a 0 velocity. We know in general motion, the velocity at any point is given by center of mass velocity and rotational velocity. Then you'll find VCM and R omega must be identical. So VC must be equal to R omega, where R is going to be the radius of the bigger one, that is roller, that is 20 centimeter diameter. So radius will become 10 centimeter. Now we need to find the speed of particle A. So position A that is in contact with the scale. We want to know what is the speed of this point. And whatever the speed of the point of the axle is, the same speed has to be of the scale, because here also no slip condition has to be applied. So speed of the particle A is going to be written as, again by using the same concept, center of mass velocity plus R omega. Now you'll find center of mass velocity is VC, R omega means this R, radius of the axle, which is, let's say, small r. And small r is going to be 5 centimeter because axle has a diameter 10 centimeter. So ultimately we can relate these two radii and we can say small radius is equal to capital R radius divided by 2. So this speed of particle A, location A, or the contact point with the scale is going to be VC plus capital R omega by 2. We know capital R omega is equal to VC again, so that becomes VC plus VC by 2, which leads to 3 VC by 2. Now we got to know if the center has a speed VC, then the point in contact with the scale is going to have a velocity 3 VC by 2. Now these are the speeds, so we can find out the distance covered just by integrating this, or we can writing this as a V is equal to dx by dt, then cancelling dt and integrating it. So you'll find the distance traveled by A point and the distance covered by C point is going to be related by the same relation. Now we know that this XC, that is the distance traveled by the center, is 50 centimeters. So XC is 50 centimeter. So what will be the distance moved by the scale? Scale will be moving by the same distance as this point has moved. So you'll find it's going to be like 3 by 2, 50 centimeter, that becomes 75 centimeter. So if the center moves by 50 centimeter, then this point of the scale will be moving by 75 centimeter. So if center is here in the new location, then you'll find the end of the scale is going to be here. That means this distance is going to be 25 centimeter. So in ultimately appearance, you'll find beyond the center towards the right, the distance or the length of the scale should go by 25 centimeter. Now let's look at the option. The first option says that this is 50 mark, that means this distance is 50 centimeter, which is not matching with our conclusion. Similarly, the second can be checked, and this is reading 25 centimeter, and we want it to be 25 centimeter relatively, so that matches. If you look at a C option, this is 75 centimeter, which is not going to match. This is 100 centimeter, which is not going to match. So you'll find is going to be the B option, which will be matching perfectly. Hence, B will become the correct response. Got it? Thank you.